Hello and welcome to this repair tutorial, and today we're going to look at a Pioneer A10 amplifier. The A10 was released around 2019 and there were two other models within the A series, so there was also an A20 and an A30. With the A10 it didn't support a remote control function, which is a little bit strange because the amplifier itself does deliver a good sound quality and build wise it's pretty good. So in terms of general specifications, you're looking at a power output RMS of 30 watts per channel into 8 ohms, and then that's 50 watts into 4 ohms with a frequency response of 20 hertz through to 20 kilohertz. And total harmonic distortion is down at 0.01%. And then in terms of inputs, this amplifier had a built-in phono, so for a moving magnet type cartridge, direct connection, you don't require any form of equalizer stroke preamplifier. You could connect a tuner, CD aux, network, and it also had a recorder output at the rear as well. From the front fascia, straightforward sort of classic design. So input selection via a rotary encoder just on the right hand side with the LEDs illuminating depending of course which input you select. Volume control, large chunky knob at the front, which is good. And then you add individual balance, treble and bass controls. And you had two sets of speaker outputs on this amplifier, so you can go speaker set A or speaker set B or both of them. You had a loudness button, which is very common, and then you can also go direct mode. So for anyone who is unfamiliar with that term, when you select direct mode it will bypass the tone control circuits. And then for dimensions you're looking at 435 by 360 by 128 high. Weight is 6.7 kilograms, and the amplifier doesn't have internally a toroidal transformer. It has a conventional EI type transformer, but I'll sort of give you a little bit more information on that as we go through. So really, what was the background to the issue with this amplifier? Well, before I directly get into that one, I'm just going to sort of talk to you with regard to common types of amplifier faults for the A10, A20 and A30. And the reason for that is if you're looking then to repair an amp, there's common faults which normally occur. And I often, and I apologize if it's repeating the same term, but you really have to take this systematic approach, okay? You know, you don't go in there almost like a kind of wild card approach, because you'll use a huge amount of time where you fundamentally won't get anywhere, and you'll kind of be looking maybe for fault symptoms which are not directly related to the issue. So this amplifier has a protection circuit, but it operates in a different mode to many of the other amplifiers. A lot of protection circuits in amplifiers will auto reset. For this amplifier, on the A20 and A30 is exactly the same. If it detects a fault and the protection circuit operates, what will happen is it will disengage the relay which is on the startup board, which will provide the power to the large power transformer, and then on the front fascia the power LED, instead of it being blue, will flash and it will just strobe red. And then even if you went in there and maybe you fixed the fault and then you re-powered up the amplifier, you'll still find that it's flashing red, indicating protection. The way in which you will clear that is that when you look at the front fascia, you need to press the speaker B push button and the direct push button together, keep them pressed for about 4 to 5 seconds, and then you'll hear the amplifier reset. Now, if all is good, then the LED for the power will remain static, blue, but if the amplifier detects another issue or the same issue, you didn't actually repair it, it'll default and then it will go into protection mode. But this protection mode can sometimes trigger under a soft failure rather than a hardware failure. So it's not uncommon that maybe you see it in protection mode, and just by simply resetting protection mode via the push button, it will continue running and you won't have any issue. But if it defaults back to protection mode, you tend to be looking then for a hardware related issue. Well, that's what you are. And the most common faults that you get with this series of amplifier is on the plus or minus 15 volt supply rail, it used the Korean Radio Corporation type regulators and the KI series, and on some of the amplifiers you will find that those are installed, and you'll find that normally the minus 15 volt rail has collapsed because the IC has failed, the regulator has failed, and that's what's triggering it. But remember, because you are able to reset, even for a short period of time, protection mode, that enables you then to get in there and make some measurements. So you would connect your negative probe lead for your multimeter onto the negative speaker terminal, and that will give you sufficient time, if you reset from the front fascia, to do a voltage measurement to verify, do you have an issue with either of those two regulators. If there's no issue there, then you also need to check, and this would verify this, that if you had voltage on the input to the regulators, then you know it's really a regulator issue. If you have no voltage, then it's the next most common fault, where the power transformer fails and the thermal fuse operates or is tripped, okay, and it's non-resettable. And this is really strange, and I've sort of commented on the description type videos that I've provided previously. If you try and source one of these transformers, it's nearly the cost of the amplifier, which is just nuts. Why any manufacturer would charge such a high price for a replacement transformer? Why would you even bother creating a partner but that someone could buy? Because no one will buy it. So what I have in stock is a toroidal equivalent, which provides greater reliability. So two most common faults: regulators fail for the plus or minus 15 volt rails, and the power transformer goes open circuit. Now the next one is really this fault that you're seeing here in a slightly different way. So what am I referring to? Well, what I show in the video is an extract from the service manual, and what you are seeing here is the startup board, and that's located on the left hand side at the rear where the power comes in. Now on that circuit board there you have a small transformer, and that small transformer will provide the power then to the regulator, and that regulator that you're looking at is IC91. Now IC91 provides a 3.3 volt signal, and that goes to the microprocessor, which is a surface mount component mounted on the front panel board, and that's both the micro board stroke tone control board as well. So it's a single board. Now you cannot source that board, so I have had incidents where I've been fault finding and the issue has gone down to the microprocessor, which has failed, and you can't replace the board. So if you encounter that, sorry to say, you're not going to be able to repair it unless you get another unit to cannibalize. You know, maybe there was a fault, you know, which is unrepairable maybe on the main board, and you can cannibalize the front board. So when you look at the multi-pin connector, when you apply power to the amplifier, this amplifier had no indication at all. So I could not see protection mode had operated, nothing. So that's telling me that I need to look at the startup board. So the first thing that I do is to verify that I have mains incoming voltage across the protection fuse, and I did, right? So either side of the protection fuse I can measure the incoming main supply, so I know that's good. And then what I then do is, rather than check the output from the small startup transformer, what I do is I look at CN94, and this multi-pin connector there has plus or minus 5 volt supply, but the one that I'm really interested in is this ST 3.3 volts, and there's two connections. So this is pins 4 and 5 on CN94. If I am unable to measure that voltage, then I know that there's no supply going to the micro, and that's what the issue here was. So you say, okay, well, you check the incoming supply, now you're telling me that the 3.3 volts is missing, so where's the issue? Well, what I show you in the video, I've removed the board, and as I've turned it over, you can see that the output pin, which is pin 1, is dry soldered, and of course it's gone through a flow soldering machine. This isn't unique to this make or model of amplifier, but often you find that the amount of solder which has been transferred to hold these components, and some, you know, quite heavy or mechanically loaded like the headphone socket, there's hardly any solder on. So that's what happens here. So it wasn't that the regulator had failed, it was that intermittent contact, and that's why the amplifier had come in for repair. A very straightforward repair, because all I need to do is re-solder the regulator, and then I could then verify that I have my 3.3 volt supply coming or present, and then I was able then to, you know, just power up the amplifier as normal. Now this circuit or extract from the circuit, of course, comes from the service manual. Now the service manual for the A10, A20, A30, and it's a single manual, is extremely good. Quite rare of an amplifier of this age. Often you find more modern amplifiers, the amount of service information or service manuals are quite poor. Here in the service manual they provide an exploded diagram, they provide detailed service information as well, and then they also provide photographs of the disassembly of the amplifier and all the different part numbers. So if you're looking to repair an amplifier, maybe for the first time, probably not a bad position, because if you have a good service data, you're going to learn a lot, and then at the same time it should enable you then to repair the amp. Now what I'm also showing in the video as well are the main board, and the main board is very easy to remove from this amp. You know, although it kind of looks complicated from the top, it isn't. Everything's multi-pin connectors, and you have two fixing screws that go into the heatsink, and then you have multiple fixing screws on the main board, and it's dead easy. You can just take it out once you remove the back panel, put it on the workbench, and then you're free to work on that main board without you kind of trying to get into there because it's bonded into the chassis, or it's one of those amplifiers which just doesn't lend itself to any form of service work. And then what I also show here is I'm showing you the headphone socket, and it's sort of coming back to that point that if you think how much mechanical stress that headphone socket has if it's been in regular use, and if you look at the amount of solder, it's really minimal. So as a general point, if you're working on any type of amplifier, go seek out the parts where you have mechanical stress and just reflow the solder. And the reason for that is, if I had an issue with the headphone socket due to dry joints, I may be looking, you know, if I'm inexperienced, maybe at a fault with the input circuit or something. You know, you're going to go down a rabbit hole then. So, or not only are you repairing a particular fault, but you're also doing remedial work, which enables the amplifier then to have this longevity, which I always mention. And then the video is also showing you as well the back of the tone control board, and then you can see on there, which is a surface mount microcontroller stroke microprocessor, and even on the board it's written with white lettering 3.3 volts. So if you maybe had the 3.3 volts at the connector, you can go up right next to the microprocessor and verify that you have the supply. And I've come across that where I had micros fail, and I've verified that it wasn't a loss of signal, you know, with the cabling from the startup board going across to the micro. It was the micro itself that had failed. Now in terms of biasing the amp, I don't need to cover that in detail here because the amplifier didn't come in for that fault. But just for your own reference, if you look in the service manual, you'll find that if you are doing the bias adjustment, there are two test connectors on the main board for the amp, and you can set that then to 8 millivolts, and that's the bias level. So yeah, so not a difficult repair as such, but you know, interesting that there was dry joints on the connector. But once repaired, all done, you know, everything was good then, and there was really nothing else, you know, that you needed to take care of. So that sort of brings us to a conclusion on this repair video. So I thank you very much for stopping by and for listening. And if you have any questions, by all means email audioamplifierservicing@aol.com, and of course I'll come back to you and give you any information that you may need to help you with your own repairs and service. Thank you very much. Bye bye.